I'm Logan from Goosereck Engineering, here to talk to you about flux core arc welding. Flux core arc welding, FCAW, is an arc welding process that creates an electric arc between our workpiece and a continuously fed electrode. This electrode has a tubular cross section that has fluxing agents in it. There are two main varieties of this, and they are gas shielded and self shielded. The gas shielded flux core arc welding electrode utilizes the same system as the GMAW process, where our wire is pushed through a contact tip that's held inside of our welding gun that has a diffuser and will have a gas nozzle. It'll have a couple different sizes so we can get into different joint designs. And we have a type that is referred to as self-shielded flux core, where we see that the self-shielded flux core gun is a little bit different. So all we have here is a contact tip with no nozzle for shielding. And we see that we've got a bit of a long neck on this, along with a heat shield. There's a lot of heat generated with the self-shielded flux core process. All right, and we see that our wire for the flux core process is going to be able to be broken really easily. And again, we'll be able to see that it's got a tubular cross section. Okay, so we're going to use a constant voltage power supply along with a direct current, and depending on the variety of flux core we're going for, will dictate what polarity we're utilizing. So for the gas shielded flux core, we're going to be using the direct current electrode positive, and for the self-shielded flux core arc welding, we're going to use the direct current electrode negative. It gives us a couple different bead profiles, and it helps manage the characteristics of each one of those wires. So when we talk about flux core, we're talking about a semi-automatic process that is coming again on our 15 kg, 33-pound spools, and we're getting really good deposition rates, okay, high productivity. We're also getting really good weld properties at low temperatures, along with being able to weld out of position. The potential there, we can weld overhead with not a lot of problems. The disadvantage of the flux core arc welding process is the fact that it is going to create a slag. So we're going to have to clean that off every single time, whether that's gas shielded or self-shielded. And we're also going to see the potential, as we see here, is that we've got a hermetically sealed wire spool. And that's part of the reason is that those fluxing agents that are in that tubular cross section have the ability to pick up hydrogen from our atmosphere. And that can induce hydrogen into our welds, which causes hydrogen-induced cracking. So that's a disadvantage. Again, we see that if we're using the gas shielded flux core, we're going to have to manage shielding gases, whether it's cylinders, bulk gases. We're going to have a procurement element. We're going to have some way to manage those on site safely. The downside to the flux core arc welding process is there's a lot of fume generation. There is a ton more fume generation in the self-shielded variety, and we've got to manage that as well. So depending on whether you're indoors or outdoors will kind of lead you to which variety you're looking to utilize. Thank you for spending a couple minutes with me today talking about the flux core arc welding process. Before we do some FCAW gas shielded welding, we need to set our machine up. So first we're going to turn our machine on. This machine in particular is a constant voltage, straight constant voltage. And since we're doing gas shielded FCAW, we're going to be on direct current electrode positive. So we're going to check here. We see that our positive is denoted by our red terminal. Our black is going to be our negative terminal. So our ground clamp or our work clamp is going to be our negative. We'll hook that to our table. All right. And then our machine's warmed up. We're going to set it. So I'm going to go to new programs just so we can run through this. I'm going to go to weld, and we're going to go to MIG, which is just a straight CV mode. And we're going to go to flux core. Our wire size is 0.45 or 1.1 or 1.2 millimeters. Our gas type in particular, we're going to be using a 75% argon, 25% CO2 mix, also referred to as a C25. So go down here, choose C25. We will confirm. And I checked with our WPS, and that says it's about 27.5 volts at about 330 inches a minute. Now that we're set up, let's go weld. I'm Logan, and we're going to do some flux core arc welding, the gas shielded variety today. My old friend and professional, Gabe, is here to join me. We're going to make a few gas shielded flux core welds. We'll take a look at them. Again, we're dealing with a slag bearing process, so we're going to be having a 5 to 15 degree drag angle. We've got to be mindful, unlike the self-shielded process, we're going to have a very short stick out. So our contact tip to work distance is going to be somewhere between 3/8 of an inch to 1/2 of an inch. And we'll have to clean the slag off of each one of these welds after we go. Mind, I'll make one first and we'll go from there, huh?
Sounds like we got the right setup in her.
Yeah, sounds pretty nice. So you can hear kind of that soft arc, and you can see from just this, this is just some of the oil that's on some of these coupons burning off. But you can tell, it's not really smoky like the self-shielded variety. And we've got a nice smooth weld profile. You can hear that nice, clean, smooth arc. And that was telling me, hey, my stick out distance was right. Hey, my drag angle's right. When it starts spitting and popping, and that's usually an indication that something that you're doing technique-wise is wrong. Gabe, you want to run one for us?
Sure will. So make sure you clean your tip out regularly too. That way it don't mess with your shielding gas.
Something to watch for in the gas shielding process. Always keep that nozzle clean. So you can see Gabe's glove is catching on fire there a little bit. Even don't let that really small, smooth and soft arc fool you. There's a lot of heat going on here. We'll do a lap joint, We'll clean a couple of these and take a look, huh?
Sir.
Whew.
Good.
Nice and spicy. Man, I love how smooth that sounds.
Nice.
Well, I don't know if the camera can see this lap joint here, is while Gabe was welding away, is that slag just started peeling off on its own. Just a little bit of tap and it just pops right off, all right? So that's a really easy way to tell whether or not, you know, you've got a self-shielded or a gas-shielded flux core. The flux on that gas-shielded flux core just comes off real easy like, right? And it gives you this really nice smooth pattern, all right? Let's take a look at some of these. Thanks for spending a little bit of time with us doing some gas-shielded flux core.